So today we're preparing for our first in-class or in Zoom exam, which will be on Thursday for our class. So looking at this, we need to solve different types of equations. And so we have different equations that we looked at and decided to go through. So the first one in front of us is 1/2, parentheses, x minus 1/3, and our parentheses equals 3/4 minus x over 6. So if you're watching this video, it might be helpful if you're going through and you're pausing and trying things on your own and then watching. So looking at this, I don't like to deal with fractions when I have an equation. But to not deal with some problems and issues I know that sometimes students have, let's first distribute this 1/2 before we get rid of the fractions. And so distributing the 1/2 inside the parentheses, I have 1/2 times x, which is 1/2 x, minus 1/2 times 1/3. So we're multiplying the numerators together and the denominators together. So 1/6 is equal to 3/4 minus x over 6. So looking at my denominators of 2, 6, 4, and 6, we're trying to find the least common denominator or a common denominator of all 4 of those numbers. Least common denominators, I'm just going to be less simplifying. And so the smallest number that 2, 6, 4 go into is 12. So our least common denominator is 12. And so we can clear the fractions just because this is an equation. And if we do something to one side of the equation, we're going to do it to the other. So we're going to multiply 12 on both sides of that equation. And then we're going to distribute it to each term on each side of the equation. And so when we distribute 12 and multiply it times 1/2 x, that 2 divides into the 12, and it gives us 6x. Or leaves us with 6x. Minus, now distributing the 12 to the 1/6, well, 6 goes into 12 2 times. So minus 2 is equal to, so again, distributing the 12 on the right-hand side now. So we have 3/4 times 12. Well, I think to myself, 4 divides into 12 3 times. So I'll have that 3 times the 3 in the numerator here. So that gives me 9. Minus, multiplying the 12 times that x over 6. Well, 6 goes into 12 twice. And so we're left with 2x. So depending on what type of equation we have depends on how we approach and go through and solve these. I notice this is a linear equation. And so how we approach in linear equations is we get all the variables to one side of the equation, all the terms with the variables, and all the terms that don't have the variables to the other side of the equation. So let's get the x to the left-hand side of our equation and the terms without the x's to the right-hand side. And so we could add 2x to both sides of our equation. And we can add 2 to both sides of our equation. Doing so, we get 6x plus 2x is 8x is equal to 9 plus 2, which is 11. Now we're just going to get x by itself, so let's divide through by 8, and we get x is equal to 11/8. Okay, so our next problem is below, and now we're looking at the equation. 1 minus 3x is in the numerator, and that's all over the number 4. Then we have this is equal to x plus 6 in the numerator, which is all over 3. And then we have outside of that fraction plus 1/2. So again, we're dealing with an equation that has fractions. And so let's go through and let's multiply by our least common denominator so that we can clear the fractions. So looking at the numbers in my denominator, I have 4, 3, and 2. So again, the smallest number that those all go into just happens to be the same one as above, which is 12. And so we're going to multiply the left-hand side by 12, and we're going to multiply the right-hand side by 12. So notice on the left-hand side, that 4 goes into our 12 3 times. So we're left here with this 3 times the whole numerator, 1 minus 3x. This is equal to, I'm going to distribute that 12, and so I'm going to put 12 next to each one of these parentheses. And so now I have that 12 times the x plus 6 over 3. Well, our denominator 3 goes into 12 4 times. And so we're left with 4 times the numerator x plus 6. Plus, and then 1/2 times 12. Well, 2 goes into 12 6 times. So we're left with 6. So let's distribute and combine like terms on each side of our equation before we start moving things around. And so distributing our 3 inside the parentheses, we have 3 times 1, which is 3, minus 3 times 3x is minus 9x, is equal to distributing our 4 inside the parentheses. 4 times x is 4x, plus 4 times 6 is 24, and bringing down our 6, so plus 6. 3 minus 9x, there are no like terms on the left-hand side, so we're going to keep it the same, bringing it down, equals. On the right-hand side, we have 2 like terms, 24 and 6. So this is equal to 4x plus 24 plus 6 is 30. So again, I'm looking at what type of equation I have. This is a linear equation, so I want variables to one side, constants on the other. And so let's subtract 4x on both sides of our equation. And let's subtract 3 on both sides of our equation. So doing so, we have negative 13x is equal to 27. Dividing both sides by negative 13, we get x is equal to 27 all over 13, and let's just put the negative out front. So negative 27/13. So the next type of equation in front of us has a radical in it. It's the cubed root of x squared minus 1, and then that's equal to 2. So solving equations with radicals. If this radical was not isolated on one side of the equation, that's what I would do first. So, and if there was more than one radical in my equation, I would just isolate one of them first. Well, there is only one in here and it's already isolated for us. So we're going to go through here and we're going to clear our radical by raising both sides of our equation by our index. So this is a cubed root, so our index is 3. We want to get rid of the radical, so we're going to cube both sides of our equation. So doing so, we get what's underneath the radical, which is called our radicand. X squared minus 1 is equal to 2 cubed, which is 8. So there's a couple of different ways that I could solve this one. I could set it equal to 0 because it's a quadratic equation, and then I could see if I could factor it. If I couldn't factor it, I could use my square root method or a quadratic formula. The other method, the square root method, I could, because there has just a perfect square here and no other term outside of the perfect square. I don't know if that makes sense. Anyways, we could isolate the x squared and then take the square root of both sides. So doing so, we would get x squared equals 9. The problem with this method is that sometimes students forget to put that plus or minus here, so they forget some of their solutions. And so we get the square root of x squared is equal to plus or minus the square root of 9. So we get x is equal to plus or minus 3. Or you could have subtracted 9 on both sides, x squared minus 9 equals 0. Notice that's a difference of 2 squares, so this would have been x minus 3, x plus 3 equals 0. So x is equal to 3, and x is equal to negative 3, setting each factor equal to 0 and solving for x. So you'll notice there's a lot of times there's a couple different ways that you can approach a problem. On the exam, I'm not going to say, use your quadratic formula to solve this. You're going to have to decide which method that you're going to want to use to solve. The next problem in front of us, x to the fourth minus 5x squared plus 4 is equal to 0. So I'm looking at this and I notice that I can manipulate this to be a quadratic equation. And so we did this with some problems when we were solving equations. If we choose some variable, I'm going to choose u, let u equal x squared. So notice that x to the fourth, that can be rewritten as x squared, quantity squared. Power to power, remember, is multiplying. 2 times 2 is 4. So those are equivalent. So we have x squared minus 5 times x squared plus 4 is equal to 0. So let's go in and replace x squared with u. And now we have u squared minus 5u plus 4 equals 0. So this is quadratic. I would see if it's factorable, which it is. There are 2 numbers that multiply to give me my constant 4, and that would add together to give me negative 5, and that would be negative 1 and negative 4. So we have u minus 4 all times the quantity u minus 1. So we're looking at when is u minus 4 equal to 0, and when is u minus 1 equal to 0. Adding 4 to both sides, we get u is 4. And then adding 1 on both sides for the other equation, we get u is 1. But we want x, not u. And so we're going to go back and substitute in what u is. So we have 4 is equal to x squared. And we have 1 is equal to x squared. So again, a couple different ways that you could approach solving for x in here. We could just take the square root of both sides, but don't forget the plus or minus. So we get the plus or minus square root of 4 is equal to the square root of x squared. So we get x is equal to plus or minus 2. Do the same thing with the other one, taking the square root of both sides. We get plus or minus the square root of 1 is equal to the square root of x squared. So I get x here is equal to plus or minus the square root of 1 is 1. So we have 4 separate solutions here, negative 2, negative 1, 1, and 2. So the next problem in front of us is very similar to what we had just done. The only problem with this one is that coefficient that's going to be in front of our square is not 1. So it makes it a little more difficult if we're going to try to factor it. Well, let's go ahead and look at this. So we could, again, use substitution if we wanted to. So we could let u equal x squared. If we did this and we went back in and plugged in, we would have 6 times u squared minus 5u minus 1 is equal to 0. So my coefficient in front of the u squared is not 1 again. And so I need to look at my AC method, or that's one way to try to factor it. So what multiplies to give us a times c that adds to give us b? So A times C is 6 times -1, which is -6, and adds to give us our coefficient B, which in this case is -5. So two numbers that multiply to -6, but adds to -5. Well, I know that one needs to be positive and one needs to be negative in order to multiply to give me a negative. And so those two numbers are going to be -6 and +1. So once you figure out those two numbers, the trick is to go back in and rewrite the middle term using those two coefficients. And so we're going to rewrite this. So we have 6u squared. And then we're going to rewrite -5u as -6u plus 1u. I'm just going to write plus u. Bringing down the -1 equals 0. So once you rewrote that middle term using the two numbers you found, then factor by grouping. So grouping the first two terms, we're going to pull out what they have in common, which is a 6u. Pulling out a 6u, I'm left with u minus 1. Plus, notice what's over on the right-hand side is u minus 1. There's nothing in common, but that's the same thing that's in my parentheses over here. So let's just put it in parentheses here. So technically, there's a 1 in front of that parentheses. And so this is equal to 0. So we're going to pull out a u minus 1. So pulling out u minus 1 from the first grouping, you're left with 6u. And pulling out u minus 1 from the second grouping, you're left with plus 1. This is equal to 0. And so we're looking at when is u minus 1 equal to 0 and when is 6u plus 1 equal to 0. So solving for u in each case, we get u is equal to 1. Subtracting 1 on the other equation, we get 6u equals -1. And dividing through by 6, we get u is equal to -1/6. But again, we want to know what x is and not u. And so we have x squared is equal to 1. And we have x squared is equal to -1/6. So taking the square root of both sides, we get x is equal to plus or minus the square root of 1, or x is equal to plus or minus 1. Taking the square root of both sides over here, I get x is equal to plus or minus the square root of -1/6. So that's not a real solution, but if I was asked to find all solutions, even complex solutions, this would be x is plus or minus I square root of 1/6. The next problem in front of us here is x plus the square root of x is equal to 20. So there's two ways I could approach this. I could manipulate it like I've done with the last couple of problems and use u substitution to make this a quadratic. Or we could look at this and isolate our radical, our square root of x, and square both sides and then solve that way. So either way, we can go about and approach that. Okay, so let's solve this by isolating our radical. And so let's subtract x on both sides of our equation. And so doing so, we get the square root of x is equal to 20 minus x. So we're going to square both sides of our equation. And so we get x is equal to, be careful, we can't just square each term in here because there's more than one term. And so 20 minus x quantity squared is the same thing as 20 minus x times 20 minus x. We want to distribute this out. So we have 20 times 20, which is 400. 20 times negative x is negative 20x. Distributing my negative x, I have negative x times 20 is negative 20x. And negative x times negative x is a positive x squared. So combining like terms, bringing down first my x on the left-hand side, this is equal to, I'm going to rewrite this in descending order of powers. So x squared, and then negative 20x minus 20x is minus 40x plus 400. I notice this is a quadratic equation, so I'm going to get everything to one side of the equation. And so we're going to subtract x, and we're going to get x squared minus 41x plus 400 is equal to 0. So looking at that, we can either try to factor it, we could go in and use the quadratic formula, we can complete the square. So looking at this right away, I'm thinking, okay, what multiplies to 400 and adds to negative 41? And I don't see it right offhand. It could be pretty obvious, I'm not sure. But a way I could approach this is rewriting 400 as a product of prime numbers. And so I know that 400, thinking of two things that multiply to 400 would be 4 and 100. 4 could be written as 2 times 2. Those are prime numbers. 100 is the same as 2 times 50. 2 is prime, but 50 is not. 50 is the same thing as 5 times 10. 5 is prime, but 10 is not. And 10 can be written as 2 times 5. So I notice that 400 is the same thing as 2 times 2 times 2 times 2. There's 4 2s. 1, 2, 3, 4. Times 2 5s. So I would look at this and I would try to start making combinations. So like 25 and 16. I think that's it. So 5 times 5 is 25. 2 times 2 times 2. I don't know if I said that 4 times. 2 raised to the 4th power is 16. Notice if you sum those, that's 41. If we make those both negative, negative 16 times negative 25 is negative 41. And negative 16 times negative 25 is positive 400. So we can factor this as x minus 16, x minus 25. So looking at this, we get x is equal to 16, x minus 16 equals 0 and x equals 16, and x minus 25 equals 0 and x is 25. Okay, so you need to be careful here. So this time we could get what are called extraneous solutions. So we could get answers that actually don't work. So they're actually not part of our solution set. And the reason I know that we can get those is because we raised both sides when we were solving our equation by an even power. And so if you do that while you're going through and solving, you need to make sure that the solutions work. And when I'm going through and grading your exam, I'm looking to see that you did this. And so we need to check. And so let's go in there and let's go in wherever we see an x in our equation. We're going to replace it with 16. So is 16 plus the square root of 16, is that equal to 20? Well, 16 plus square root of 16 is 4. That is equal to 20. So 16 is a solution. So now let's go in and let's plug in 25 wherever we see an x in our equation. And so we get 25 plus the square root of 25. Is this equal to 20? Well, 25 plus square root of 25 is 5, does not equal 20. And so 25 is not part of our solution set. And the only answer that we get for this equation is 16. We have the equation t raised to the 1/2 power minus 2t raised to the 1/4 power plus 1 is equal to 0. And so I can tell that this looks like a quadratic equation, or we can manipulate it to be quadratic. And so let's let u equal t to the 1/4 power. So rewriting this first term as t to the 1/4 power. Well, if I take t to the 1/4 power and I square it, so 2 times 1/4 gives me that 1/2. That gives me what I wanted. So minus 2 t to the 1/4 plus 1 is equal to 0. So now let's go in and replace t to the 1/4 with u. So we have u squared minus 2u plus 1 is equal to 0. I would see if it's factorable, which it is. There are two numbers that multiply to give you a positive 1 and add to give you a negative 2, which is -1 and -1. So we have u minus 1 equals to 0 is when u is 1. That occurs twice. So now I want to go in and I want to actually figure out what t is. And so let's go in here. We have 1 is equal to t to 1/4 power. So I want to get rid of that 1/4 power. So again, rules of exponents, power to power is multiplying. So we could raise both sides of our equation by the 4th power. So I get 1 to the 4th is 1 is equal to t to the 1/4 to the 4th is t. So notice in here, while I was doing this, I raised both sides to an even power. I raised both sides to an even power. So let's go in and let's check our solution. So I'm going back into my original equation, and we want to know, is this true? So is 1 raised to the 1/2 power minus 2 times 1 raised to the 1/4 power plus 1, is that equal to 0? Well, 1 raised to any power is 1. The other thing that you might remember is that if you had 1 to the 1/2 power, that 1/2 power, that rational exponent is the same thing as square root of 1. 1 to the 1/4 power, this is the same thing as the 4th root of 1. Well, square root of 1 is 1. What can I raise to the 4th power to get 1 is also 1. So rewriting these, I get 1 minus 2 times 1 is 2 plus 1. Is that really equal to 0? And it is. So we're good. We found our solution, and that's t is equal to 1. So our next equation, x squared minus 3x minus the square root of x squared minus 3x, and then equals 2. So I notice that I have a radical. So I want to isolate my radical on one side of the equation, and I want to get everything else to the other side of the equation. Let's add the square root to both sides, and let's subtract 2 on both sides. So doing so, I get x squared minus 3x minus 2. And this is equal to the square root of x squared minus 3x. So we want to get rid of our radical, and we can do so by squaring both sides of our equation. Unfortunately, I'm going to have to multiply out x squared minus 3x minus 2 all times x squared minus 3x minus 2 is equal to squaring the square root gives us the radicand, x squared minus 3x. Okay, so distributing this out, I'm going to take the first term and distribute it to each term in the second parentheses. So x squared times x squared is x to the fourth. X squared times negative 3x is negative 3x cubed. X squared times negative 2 is negative 2x squared. Now I'm going to take my negative 3 and I'm going to negative 3x and distribute it to each term in the second parentheses. So negative 3x times x squared is negative 3x cubed. Negative 3x times negative 3x is plus 9x squared. And negative 3x times negative 2 gives me plus 6x. Now taking my negative 2 and distributing it to each term inside the second parentheses. So negative 2 times x squared is negative 2x squared. Negative 2 times negative 3x is plus 6x. And negative 2 times negative 2 gives me plus 4. Is equal to our other side, x squared minus 3x. Okay, so looks kind of nasty, but we can do it. Let's combine like terms. We only have an x to the fourth, and let's, as we're doing that, maybe you can subtract x squared and add 3x. So I have x to the fourth. So I'm looking at all of my cubes. I have a negative 3x cubed minus a 3x cubed is a minus 6x cubed. Now I'm looking at all my terms that are squares. So I have my minus 2x squared minus 1x squared right here. That's a negative 3x squared. Negative 3x squared plus 9x squared is 6x squared, and 6x squared minus this 2x squared is plus 4x squared. Looking at all the terms that just have the x. So over here, we had our 6x plus 3x is 9x. 9x plus this 6x is plus 15x. And then plus 4 is equal to 0. So looking at this, we don't have the tools in our tool belt yet to solve this. Later on in this course, we're going to look at solving zeros or roots, another way to say that, of polynomials. And we could use the rational zero theorem here to figure out what values of x would set that equal to 0. So we need to go back and we need to approach this problem a little differently. So looking at this and knowing what section I'm in, and this looks like we could rewrite this as a quadratic. Notice what's underneath this radical here. X squared minus 3x is the same thing right here, x squared minus 3x. So if we chose u to equal x squared minus 3x, right now we would have u minus the square root of u is equal to 2. So I can go in here and I could rewrite this in terms of another substitution, because I could see that this is going to be quadratic. Or I can go in and I can do what we had just done, isolate the radical and approach it that way. So let's just do it that way, because I think doing another u substitution, we'd have to go back and resubstitute to figure out what x is twice. So instead, let's isolate our radical. So let's subtract 2 on both sides, and let's add the square root of u on both sides. So if we did that, we would have u plus 2 is equal to the square root of u. And I said subtract 2 on both sides. So it should be u minus 2 equals the square root of u. So we isolated the radical. We could square both sides now. So doing that, we have u minus 2 times u minus 2 equals square root of u squared is u. Distributing out u minus 2 times u minus 2, we get u squared. We have a negative 2u and a negative 2u. So summing those is a negative 4u. Negative 2 times negative 2, so plus 4 equals u. Notice that this is quadratic, so I want to set this equal to 0. So let's subtract u on both sides. Subtracting u on both sides, we have u squared. We have a negative 4u minus u, so minus 5u plus 4 equals 0. So this is factorable. There are two numbers that multiply to give us our constant 4 and add to give us negative 5. That would be negative 4 and negative 1. So this is u minus 4 all times u minus 1 equals 0. So u minus 4 equals 0 when u is 4. And u minus 1 is equal to 0 when u is 1. But we want x again. And so we're going to go back in here and we're going to have two separate equations. We're going to have 4 is equal to x squared minus 3x. And we'll have another equation, 1 is equal to x squared minus 3x. So both of these are quadratic equations. So approach that by setting it equal to 0. So first equation, we're going to subtract 4 on both sides of our equation. Doing so, we get x squared minus 3x minus 4 is equal to 0. There are two numbers that multiply to negative 4 and add to negative 3. So we can factor this as x minus 4, x plus 1. Oops. So in that case, let's see. And so in that case, we'll set each piece equal to 0. So we have x minus 4 equals 0. And we have x plus 1 equals 0. So add 4 to both sides, we got x equals 4. Subtract 1 on both sides, we have x equals negative 1. So looking at the next equation, we want to set this equal to 0. So we would subtract 1 on both sides. Doing so, we would have x squared minus 3x minus 1 equals 0. I notice that this is not factorable. And so I can go about this and I can approach it by using the quadratic formula. So x is equal to negative b. So negative of a negative 3 is 3, plus or minus the square root b squared. So negative 3 times negative 3 is 9, minus 4 times a times c. So 4 times 1 times negative 1. So 4 times 1 times negative 1 is negative 4, but it's a minus a negative 4, so we really have plus 4. All over 2 times a. So 2 times 1 is 2. So I have 3 plus or minus the square root of 13 all over 2. Okay, so looking at this, we had squared both sides of our equation, so we have to go back and we need to check our solutions. And so we want to go back here and we want to go back and plug in x equals 4. We already did. So let's go back, actually, yeah, and we're going to plug it back into our original and see, is this true? So wherever we see an x, we're going to plug in 4. So is 4 squared minus 3 times 4 minus the square root of 4 squared minus 3 times 4 equal 2. So I have 16 minus 12 minus the square root of 16 minus 12 is 4. Square root of 4, does this equal 2? 16 minus 12 is 4. Minus square root of 4 is 2. 4 minus 2, is that equal to 2? It is. So x equals 4 is a solution. So now we want to look at x equals -1. So plugging that back in for x in our original equation, we want to know is -1 quantity squared minus 3 times -1 minus the square root, -1 quantity squared minus 3 times -1. Is this equal to 2? Well, -1 quantity squared is 1 plus 3 minus the square root, -1 squared is 1 plus 3 underneath the radical we'll have a 4. Is that equal to 2? 1 plus 3 is 4 minus the square root of 4, which is 2, is equal to 2. So the other piece I would throw into a calculator to see if that was true or false. And that those don't work. And these are our solutions. So our next equation, we have in parentheses y, and that y is all over y minus 1. And then that's quantity is squared. This is equal to 6 times parentheses y all over y minus 1 and the parentheses plus 16. So looking at this again, we can make this a quadratic by choosing u to be what's inside that parentheses. So if we let u equal y divided by y minus 1. So doing that, we have u squared is equal to 6 times u plus 16. Quadratic equation. So we want to set our equation equal to 0. So let's subtract 6u. So I have u squared minus 6u. And subtract 16 on both sides. So minus 16 is equal to 0. Looking for two numbers that multiply to -16 and add to give us a -6. That would be a -8 and a +2. So we're looking at when is u minus 8 equal to 0? That's when u is 8. And we're looking at when is u plus 2 equal to 0? And that's when u is -2. So we're going to have two separate equations. We're going to have y divided by y minus 1 equals 8. And we're going to have y all over y minus 1 equals -2. So we want to solve for y here. We can clear our fraction by multiplying by our denominator, y minus 1 on both sides of our equation. So the whole purpose was to get rid of our denominator. The y minus 1s cancel on the left-hand side, and we're left with 8y is equal to, distributing the 8y minus 8. So let's isolate y, subtract 8y on both sides. We get -7y equals -8. Divide through by -7, we get y is equal to -8 divided by -7 is +8/7. Solving the next equation, y all over y minus 1 equals -2. Again, we're going to clear our fraction by multiplying both sides by our denominator, y minus 1. Y minus 1's cancel on the left-hand side, leaving us y is equal to, now distributing our -2, we have -2 times y is -2y, and -2 times -1 is +2. Adding -2y, or adding 2y to both sides, we get y plus 2y is 3y is equal to 2. And then divide both sides by 3, we get 2/3. We did not square both sides of our equation, so we don't have to worry about getting a solution that doesn't work. We do have to be careful though, because we do have a variable in our denominator, but our solutions don't set the denominator equal 0. We could not have had y equal to 1, so y cannot be 1, but that was not one of our solutions. And so those are our two solutions, 8/7 and 2/3. So our next equation problem we have is find the equation of a line that passes through 3, -7 and is perpendicular to the line 6x plus 2y equals 8. So lines are perpendicular if they have the negative reciprocal slopes of one another. And so in here, we want to solve for y, so we can tell what the slope is. We want to put this in y equals mx plus b form. Once it's in this form, we can tell what the slope is. And so let's isolate the term with a y in it. So let's subtract 6x on both sides. If we do that, we get 2y is equal to -6x plus 8. And then let's get y by itself. You need to divide every single term by 2 on both sides of the equation. Doing so, we get y is equal to -3x plus 4. So the slope of this line is -3. So the slope of our perpendicular line is the negative reciprocal of that. So -3 can be written as -3/1. So taking the reciprocal, it's 1/3. And the opposite sign, so it's going to be +1/3. So we're using the slope is going to be 1/3. And we're given that the point is 3, -7. So there's a couple different ways you can approach this. You can use your slope, point slope form of an equation of line, or we can go back and use y equals mx plus b. We can plug in our values for y. So y is -7 here, is equal to our slope, which is 1/3. Times x in our case is 3, plus b. So we have -7 is equal to, well, 3 times 1/3 is 1. 3's cancel. Plus b. Subtract 8 on both sides to get b. So we get b is -7 minus 1 is -8. So we know what our y-intercept is, and we know what our slope is of the line. So our perpendicular line to 6x plus 2y equals 8 that passes through 3, -7 is y is equal to 1/3 x minus 8. The difference quotient is something that I want you guys to know that is something that you'll use a lot when you're in calculus, or at least the beginning of the semester. And recall the difference quotient is f of x plus h, and your parentheses, minus f of x, and both of those are all over h. And so, for instance, let's say that you had f of x is equal to x squared minus x minus 1. And it asked you to find the difference quotient of f of x So you can do this in pieces if you want, but technically for f of x plus h, we're going to go in wherever we see a parentheses, we're going to drop in x plus h. So when I'm evaluating a function at a number or an expression, I like to go and put parentheses wherever I see the x, and then go in and plug in what I'm evaluating it at, in this case, x plus h. I'm going to need to expand this. So I'm going to need to look at what is x plus h times x plus h. To save time, I'm going to do it in my head. That would give us x squared. We would have plus a 2xh plus an h squared. So that is if you multiply x plus h times x plus h, we would get this back. Be careful when we have negatives. We need to carry that negative inside the parentheses. So this is going to give me minus x minus h. And then I have a minus 1. So that was just my first piece in my numerator. If I'm looking at negative f of x, this is saying I'm going to multiply my equation f of x by negative 1. So I need parentheses around the whole equation. So I have negative of x squared minus x minus 1. So if I distributed my negative 1 to each term, this would give me negative x squared plus x plus 1. So putting everything together, our f of x plus h minus f of x all over h. Well, our f of x plus h we just found was the x squared plus 2xh plus h squared minus x minus h minus 1. Minus f of x, well, we just found minus f of x was minus x squared plus x plus 1. And we're putting this whole thing over h. So things should start canceling out. We have a positive x squared minus an x squared, those cancel. I have a negative x plus an x, those cancel. I have a negative 1 plus a 1, that cancels. So notice that all of our terms that are left in our numerator all have an h in common. I have this 2xh plus an h squared minus an h. So I can technically factor out the h from all 3 of those terms that are left. So pulling out an h from all 3 of those terms, pulling an h out of 2xh, I'm left with 2x, plus pulling an h out of h squared, I'm left with a single h, minus pulling an h out of negative h, I'm left with minus 1. And this whole thing is over h. And so now my h in my numerator, I can cancel with my h in my denominator because it's multiplication in between that. And so we're left with 2x plus h minus 1. So that would be the difference quotient for f of x that was given. Okay, so we have time to do one more problem. So given the piecewise function g of x, we're given g of x is equal to 2x minus 2. If x is less than negative 2, we're giving it negative x squared minus 2. If x is between negative 2, including negative 2, and 1, but not including 1. And it's equal to 4 if x is greater than or equal to 1. So first part was we want to graph this. So when you're graphing these, you want to make sure that you're staying within your domain for each equation. The only thing is, if you have an endpoint of your inequality, you want to see what's happening there no matter what. And so even if it's not included. So in this case, negative 2 is not included, but I want to see what's happening at negative 2 for this first equation, y equals 2x minus 2. So if we plug in -2 wherever we see an x there, we get 2 times -2 is -4, and -4 minus 2 is -6. This is an open circle because it's not included there. It's strictly less than. So at -2, -6, I have an open circle here. So now choosing numbers, they have to be smaller than -2 to plug it into the top equation. And so -3 is smaller than -2. And so plugging in -3 and for x, 2 times -3 is -6, -6 minus 2 is -8. So at -3, I have -8. So I know that this is a line. And so I would be going down, going to the left. Now I'm looking at my second piece, or my second equation. And I have -x squared minus 2. I need to see what's happening at my n values of my inequality. So I want to see what's happening at -2. So in this case, y again equals -x quantity squared minus 2. So if I plug in -2 and I square that quantity, -2 times -2 is 4, but I have the negative out front. So that's -4 minus 2 is -6. And this is a solid circle. But notice -2, -6 was where my open circle was from my other graph. So I'm going to fill that in now. It's now solid. I know that this, by transformations of graphs, this -2 is shifting it down 2, and this negative in front of the x squared is reflecting it across the x-axis. So knowing that, I actually know at 0, I'm going to have a vertex. So at 0, I get back -2. And 0 falls between -2 and 1, so I'm okay. And then plugging in 1 here, I get -1. 1 squared is 1 times the negative in front is -1. -1 minus 2 is -3. And this is a open circle because x is strictly less than 1. So 1, -3, open circle. So we have a parabola, upside down parabola shape right there. I don't want to extend that graph past -2 or 1. And then the last piece, I just have g of x equals 4, and that's for x is greater than or equal to 1. So I have a horizontal line at 4. At 1, it is a solid circle, so 1, 4 is solid, and then it's a horizontal line going off to infinity. So now looking at this, I can answer information about my graph. So what is the range? Range are all the x values that are included. And it wants us to write our answers in interval or inequality notation. I used to always just have it be interval notation, but I'm getting more lenient. So looking at this, these are all our y values we're hitting. We're hitting all the y values coming from -infinity until I hit -2, and it's including, so -infinity to -2 bracket. Union, the only other y value that I'm hitting is 4. So it's just the number 4. Or if I was to do that in an inequality notation, it is y is less than or equal to -2 or y equals 4. Where is this graph decreasing? So going left to right, where is this going down? We're using the x values when we're going down. And the x values where I start to go down is at 0. And I stop at 2. So from 0 to 2, we're decreasing. Or that's where x is between 0 and 2. Where is it increasing? So where is it going up when we're looking at the graph? Going from left to right. Again, we're using the x values. So the x values that we're going up are from negative infinity all the way until we hit 0. So negative infinity to 0, or when x is less than 0. Where is it constant? Well, that's where we have a horizontal line. We're looking at the x values. So it's starting when x is 1. And it's going until I go to infinity. So 1 to infinity, or x is greater than or equal to 1. What is g of negative 2? So when x is negative 2, we want to look at which equation we're using. So negative 2 is not strictly less than negative 2, so I'm not going to use the first equation. Second equation, negative 2 falls in that interval. Negative 2 is less than or equal to x. So g of negative 2, we're plugging a negative 2 into the second equation. So let's put a parentheses wherever we see an x. We have a negative parentheses squared minus 2. Plugging in negative 2 where I see an x, I got negative 2 squared is 4 times the negative out front is negative 4 minus 2, which is negative 6. And that was the last piece of that problem. So we didn't get to go through everything that we've covered so far in the course, but we went through a lot of important pieces that you should know how to do. So looking at the following, we have x squared plus y squared minus 6x plus 2y plus 9 equals 0. The directions told us that we want to put this circle in standard form. We want to identify what the center is, what the radius is. We want to graph it, and we want to find any intercepts if they exist. So looking at this, when you're looking at a circle, you want to group all your x terms together, you want to group all your y terms together, and you want to get the constant to the other side. Standard form, it looks like, and this is what we're trying to get to, x minus h quantity squared plus y minus k quantity squared is equal to r squared. When it's in this form, we can tell what the center is, and that will be at hk. And our radius is r. So the square root of the number on the other side. So rewriting this, I have x squared minus 6x. I'm going to put a spot here because I'm going to need to complete the square on my x terms to make this a perfect square. So I'm going to add some number here, and I'll figure out that number in a minute. So plus, we're grouping our y terms together. So y squared plus 2y. Again, I want to add something in here to make those y terms a perfect square. So I'm going to leave some room. Is equal to, well, let's get the constant to the other side. So subtracting 9 on both sides equals negative 9. But I'm going to add something for my x terms. So I'm going to need to add that same thing to the other side of the equation. And I'm going to add something for my y term. So I also have to add it to the side of the equation. So I'm looking for the number that, same number I would add to give me negative 6. And that number I find, I'm going to square it. So basically you're taking half of this number, half of negative 6 is negative 3. Negative 3 plus negative 3 is negative 6. Now multiply it together. Negative 3 times negative 3 is 9. So I want to add 9 to make that a perfect square. So looking at my y terms and figuring out what I need to add to make this a perfect square, well, I'm looking at half of 2, which is 1. 1 plus 1 is 2. And now the term I'm adding is the square of that number, 1 times 1, which is 1. So I've manipulated this so that my x terms, x squared minus 6x plus 9, can be rewritten as a perfect square. That same number you're multiplying to give you positive 9 and adding to give you negative 6 is negative 3. And so it's x minus 3 quantity squared plus, so rewriting y squared plus 2y plus 1 as a perfect square, you're going to have y plus 1 is equal to, well, negative 9 plus 9, those cancel, plus 1 gives us 1. So it's now in the standard form. Our center is equal to, it's the opposite signs. So positive 3 is our x value and negative 1 is our y value. And our radius is equal to the square root of 1, which is still 1. So let's go through and let's at least graph part of this. So 3, negative 1. So I'm going to go over 3, down 1. That's my center. And so I can go up 1, and that would give me a point on my circle. I could go to the left 1 from my center. That would give me a point on my circle. And I can go down 1. That would give me a point on my circle, and to the right 1. So looking at where my center is and what my radius is, I see that this does not cross the x-axis. So there's no, I'm sorry, it doesn't cross the y-axis. There's no y-intercept. And I can tell that it's touching my x-axis at 3, 0. So my x-intercept, there's only 1. And this is when x is equal to 3. Technically, you should be able to solve this algebraically and not just looking at it. So recall y-intercepts. We're going to let x equal 0 and solve for y. If you went in here and you let x equal 0, let's do it into the equation we just got. That way, things are going to just fall out really nicely, really fast. If we plug in 0 for x, I get negative 3 quantity squared, which is 9, plus y plus 1 quantity squared equals 1. I can use my square root method because I have that perfect square. So let's isolate that perfect square by subtracting 9. So I have y plus 1 quantity squared equals negative 8. Right here, I can see there's no solution because when I take the square root of both sides, the square root of negative 8 is not real. It's an imaginary number. And so that tells me that it's not going to cross the y-axis. So same sort of idea for solving for the x-intercept. X-intercepts, we know that y is 0, so we're going to let y equal 0 and solve for x. So go in and let's plug in 0 for y this time. And so doing so, we get x minus 3 quantity squared plus 0 plus 1, so that's just 1 quantity squared, equals 0. So I have x minus 3 quantity squared. It's not equal to 0, equals 1. Looking at my not original on this one. So if I subtract 1 on both sides, I get 0. Now we can use the square root method. So take the square root of both sides of our equation. So I get x minus 3 is equal to plus or minus the square root of 0. Well, that's just 0. And then add 3 to both sides, I get x is equal to 3. So I showed it algebraically. I saw it visually after I graphed it. So a couple other things that you should be able to do with this problem, you should be able to tell me what the domain is and what the range is. So looking at this, my domain, which are all my x values that I'm using, well, my center was at 3, -1. So if I go to the left one and to the right one, I'm hitting all the x values from 2 to 4. Another way to write this is 2 is less than or equal to x is less than or equal to 4. My range, so going down from my center from -1, I hit the y value of -2, and going up, I hit y equals 0. So my range, my y values I get from smallest to largest is -2 to 0, or I could write that as -2 is less than or equal to y is less than or equal to 0.